Okay, Madison, let's try to figure out what's going on in 1C. Before we start doing the work, let's just talk about what's happening. You've got water going into a container and water coming out of a container. Don't worry about the fact that it's a pipe. That's not really important. Water's going into a pipe and then water's coming out of the pipe. The pipe has water. You want to ask it almost easy if you think of the pipe as a tank. What do we know about that tank? Well, the rate which is going in here is in green and then in red. I know it's not super hard to show, but you should probably have that on your calculator. And then here's the thing that's really important to get. When the green is less than the red, that means less water is coming in than coming out. So the tank or the pipe, the water level is decreasing. When the green is bigger than the red, or the R is bigger than the D, the rate going in is bigger than the rate going out, the water level is going up. So before we do the actual mathematics of it, make sure you understand the question's not that, the answer is pretty obvious, okay? Just look at the picture. Until this moment in time, 3.2716, the red line is above the green line. And so that means that there's more water leaving the tank than coming in. And then what happens at that point in time is the green now passes up the red. Since the green is bigger than the red, that means the water level is going back up. So clearly the answer has to be at the 3.2. But the question is, how do we answer the question in terms of the exam? At what time is the water the minimum? Justify your answer. How do we actually mathematically justify it? There are two ways, okay? There are two ways. The way that we originally did this, for absolute max and min, we have to check our endpoints and our critical numbers. Now this is kind of a pain. It's not as easy as the second way we're going to do it. But this is, how do I put this? This is more robust. You can always use this method. That's why we learned it, okay? You check the endpoints and the critical numbers. The biggest number is going to be the max. The smallest number is going to be the min for the y value, okay? So how much water is in the tank? Now, let's think about how much water is in that tank. We have to come up with a formula. So for 1C, well, we know for the amount of water in the tank, remember there's three factors for the water in the tank. There's the amount of water that we started with, plus the amount that we added, minus the amount that we're going to subtract. So you have to kind of read the question. How much water was in there when we started? You got to read through the 30 cubic feet of water was in there before we started. Now, the amount that you added is we're going to have to integrate the green, okay? We want to integrate the green. Because the area under the green curve is the water going in to the tank. So I want to integrate from 0 to t of r of x dx. Now don't panic. We don't actually, you're not going to get in trouble on the test or anything like that. If that's t, then that has to be some other letter, so I just picked x. Because later on we're going to want to make this w, and then I made that t, because I left it as x, but don't worry about that. So I have to integrate r, the rate in which the water is going in, to get how much water was added, and then I have to subtract the integral of d of t dt, because that's the amount of water that's being removed. And you can kind of tell by looking at the graph what's happening here. Notice there's this area here, so that means water is being removed, and there's an area here where water is being added, because the other one's going to cancel out, right? So you'll notice that until 3.2, there's the water level is going to go down, and then it's going to go back up. And that's why, just intuitively, we can see that the minimum is going to be at 3.27163. But to justify your answer, the calculus part, you have to do this. You can put this in your calculator. You can put 8 in. Well, let's put 0 in. If you put 0 in, obviously we're just going to get 0. That's kind of silly. Then you want to put the 8 in, and then you have to add that up, and that turns out if you put 8
that turns out to be, when you add it all together, don't forget the 30. Although that really isn't super important in this particular question, because they didn't ask you how much water was in the tank, they asked you at what time. So if you forgot the 30, you probably actually would be okay on this question. Turns out there's a little more than 48 and a half cubic, what's the freaking units on this thing? Cubic feet. Now, when you put, then the last one you put 3.2 in. Now, obviously, you're going to want to store that in, A on your calculator, so you're not typing that into these, integrals when you're typing them all in. And obviously, using a calculator to get these answers. You get 27.54366. You just need to have more than 4 decimals. I'm putting a whole bunch just because I have a bunch. Okay, so the answer is T is 3.271, or you could write 3.272. Truncating around it is fine. What is the justification? The AP exam and all calc teachers basically acknowledge the justification for an absolute max or min is when you've checked the endpoints and you've checked the critical numbers, and then what you end up with is the smallest number is the max, or is the min, and the biggest number is the max. So the max would be at 8. That's basically answers the question, but I think there's another way to answer this question that we talked about. Remember, we learned about absolute max and min before we did relative max or min. Here's another rule. Second way of answering this question. I'll put a little dotted line here. I think this is a cleaner way of answering the question, but the problem with it is it doesn't always work. This only works if there's one critical number. Okay? If there is only one critical number, which there is in this case, T equals 3.71, oh crap, hold on. Let me just erase that. 271. If there's a critical number and it's a relative min, and because it's pretty clear it's a relative min by looking at the picture, it's also an absolute min. That would also be a justification for the answer. There's one critical number, it's a relative min, and if it's a relative min for a critical number, it's also the absolute. If a function, let me just give you the visual on this. If a function always goes down and then goes up, that's got to be a relative. It's also got to be an absolute min. If a function always goes up and then starts to go down, it's got to be a relative max, and it's also a absolute max. This only works if there's one critical number, because as soon as there's two critical numbers, all bets are off, aren't they? That relative is not an absolute, that relative is not an absolute. So it's up to you how you want to answer it. Typically we do it this way because that's the way that most calc classes teach it. You check endpoints and critical numbers, but there is an exception for one critical number. If there's one critical number, then you can use that one critical number to justify a max or a min. If that critical number is a relative min, then that also is an absolute min. If that critical number were an absolute max, it would also be an absolute max. So there is a second way of answering that question. So hopefully that answers your question.